someone who was dating a particle physicist. And his girlfriend, apparently, whenever there was a significant event at the particle collider, she would call and say, "Sorry, I got to cancel our date tonight." And his thought was, quantum mechanics is affecting my life in a rather significant way because it determines whether I get to go out on a date tonight or not.
Yeah.
So, and if you think about it, you probably come across butterfly effect or things like this. Small things probably in the end do have large influences.
Sure, yeah.
Butterfly effect usually refers to the idea that the weather is chaotic. And so the flap of a butterfly wing today can determine whether there is or isn't a hurricane a week from now. And so almost certainly quantum effects ultimately affect large-scale life in a complicated way that's hard to predict.
So you are the associate professor in physics at Wake Forest, correct?
Correct. I'm one of the associate professors there.
Dr. Eric Carlson.
Right.
Awesome. What is there anything specific you guys are working on right now, or?
Well, my research is theoretical physics. My training is in particle physics, so trying to understand what the universe is at the smallest and most fundamental level.
So excited to talk to you, man.
And my current research is mostly on variations on theories of gravity. So the standard theory of gravity is Einstein's general theory of relativity.
Right.
I think everybody knows in the physics community that ultimately this will be supplanted by something else, but we have no idea what.
Yeah, because we don't really understand what gravity is exactly, right?
Well, in Einstein's theory, it is the curvature of space-time. And the problem with that theory is that it seems to be incompatible with quantum mechanics.
Right.
But in science, everything has to fit together. So we must ultimately have a theory that incorporates both quantum mechanics and gravity, and that doesn't exist.
The theory of everything.
Yes, we would like to get a theory of everything.
Yeah, because is there, I have so many questions. I don't want the hopper to get clogged. So, with that in mind, is it possible that, I know you're familiar with the Nobel Prize from last year, at the end of last year.
Oh, I don't keep track of which one gets which year. What was last year's about?
It was, so 3 physicists received the Nobel Prize in the study of quantum entanglement. They were dealing with the John Bell theorem.
Yeah, so I am familiar with Bell's theorem, Bell's inequality.
Bell's inequality, yeah.
So if you go back to the roots of quantum mechanics, there were a lot of people that were dissatisfied with it, most notably Einstein.
Right.
And but many others, and a lot of this discomfort exists to this day. And one of the things that really bothered a lot of people, including Einstein, who famously said, God doesn't play with dice, is that in the standard interpretation of it, it has probabilities. And people didn't like that. They said all of the rest of physics up until now has been completely deterministic. If you put something in, you know exactly what's going to come out later, at least in principle. And so there was this consideration so there's lots of examples in everyday life where we have probabilities. If I flip a coin and I hide the outcome from you and I say, what do you think, heads or tails? You'd say, well, 50% chance each. But you would presumably believe the coin is either heads or tails. You don't think that it's really both somehow. You think it's one or the other. You're just not sure which one. And so that bothered. The problem is in quantum mechanics, the way we write it is that the way we think about it is that it is inherently probabilistic. The answer to such questions in some cases is it's a little bit of both. And that bothered people. And then only when you perform the observation does the outcome become certain.
It's like Schrödinger's cat.
Yeah.
Yeah.
So Schrödinger's cat was taking this to an absurd level,
right.
But it's the same idea. And
it's really, I think the question isn't, is the cat alive or dead? Is the cat really there?
Well, right. I guess in I was just going to get to Bell's theorem first.
Yeah, sorry.
So some people thought, well, the answer is just like the coin. It has a definite answer. Somehow our just theory is incomplete and doesn't tell us the answer. And Bell's inequality shows that the predictions of quantum mechanics lead to probabilities that are incompatible with this idea that things really are definite, just hidden from us. So it gets rid of the philosophy of hidden variables, which says it has a definite answer. We're just not sure. We just don't know what it is.
Right.
So you asked about Schrödinger's cat. Schrödinger's cat.
Well, before we get to that one,
sure.
On Bell's theorem, so what these three physicists discovered with their research and why they won the Nobel Prize is because they determined that if it's not being observed, it's not physically there, basically. So if two particles are entangled, and no matter their distance, they're always entangled with each other. If you measure them,
so typically a lot of these experiments, and I don't remember which ones were these, typically what they end up showing is that it must be in an indefinite state before the measurement occurs. Mm-hmm. And in some cases, it even becomes ambiguous what order measurements are occurring. So you can have weird apparent effects where you measure something and it kind of goes back in the past and affects the other half of the experiment. But that depends on how you look at quantum mechanics. The outcomes of the experiments are clear. How you interpret it is more complicated.
Yeah. Well, according to their research and their study, they what they determined was that the reason the particles are connected, or the reason the particles are entangled is well, I guess just so the audience knows, the problem is that if these two particles are actually entangled and there's information connecting these particles at infinite distances, then that information would have to travel faster than the speed of light to keep them entangled.
Right. And so this is a classic experiment. It's called the EPR. It stands for Einstein, Podolsky, and Rosen experiment, where you would take two particles, you would entangle them, and then you would absolutely show that one of them, the properties of one are entangled with the other. So typically you describe it in terms of something called spin, which can be up or down. And if one of the particles is spin up, the other one is spin down.
Always a mirror.
And in these, the experiments are usually done with light, but this is a simple example of the spin is kind of easier to understand.
I believe they used photons.
Yeah, almost certainly they used photons, because photons are so much more easy to manipulate. Where, adjusting mirrors and something, we do that for breakfast as physicists. Not me, I'm a theorist, but the actual experiment with spinning particles is a lot harder to do. Yeah. But yes, the experiment. The standard interpretation in quantum mechanics says that when you measure something, it affects one of the two particles. It instantly affects the other one, which seems absurd because according to Einstein, information never travels faster than light. And the surprising thing is that the predictions of quantum mechanics are right. So it really looks like they are entangled in that sense. And there is this, they call it spooky action at a distance, where the measurement of one suddenly affects the other. Yeah,
and they Einstein had that famous, and I'm going to paraphrase it, but the quote where he asked his colleague, he said, "Surely the moon is there if I'm not looking at it, right?"
I mean, if you look at somebody like Heisenberg, who plays a big role in early quantum mechanics as well, he was influenced by philosophy, and a philosopher will tell you that the best a theory can do is tell you what's going on when you observe things, not when you don't observe them.
Right.
And so his whole Heisenberg matrix mechanics was all set up sort of on the idea of I do a measurement and then I do another measurement, and in between we're not going to talk about what happens because we're not doing measurements. And that bothers physicists a lot. But just because you can't see it, you can often do indirect things that indicate that something is there. So you asked about the cat. I would say that the quantum state of a Schrödinger's cat is that there's definitely a cat there, and what's uncertain is whether it's alive or dead. Obviously, experimentally, if you aren't measuring, you don't know if there's a cat there.
Right. I have another question about that too, but back to the entanglement. what they concluded with their research is that the particles, the reason they're entangled and the reason the information can connect the particles at any distance is because there is no distance. It's because there's no time or space. It's all a perception. It's just information. It's almost
Well,
like a singularity of information.
this is the kind of thing where you cannot experimentally determine all you can experimentally determine is what you observe.
Right.
You can't figure out why it's happening.
I think they use photons from stars or something. You'll have to read the paper. It was interesting.
Yeah, so all kinds of experiments along these lines have been done, and more will be done in the future.
Yeah.
But what we find every time we've done it is that the predictions of quantum mechanics are correct. And that's startling because quantum mechanics says things like a pair of photons can be separated arbitrarily, literally coming from stars, and still be entangled.
Yeah.
And that's kind of surprising. Now, there are different interpretations of quantum mechanics. One of the more popular ones is very bizarre, probably the most bizarre of all, the many worlds interpretation.
I was going to get to that. That's the Schrödinger's equation, right? Yeah.
So Schrödinger's equation actually is predictive in the sense that if you give me the wave function at one time, I can, in principle, predict it at all future times. And so there's nothing probabilistic about it. The only thing that's probabilistic in the standard interpretation of quantum mechanics is measurement. And people who believe in the many worlds interpretation would, like me, would say, okay, now if you perform a measurement, you aren't actually measuring. What you're doing is you're getting involved in the system.
Right.
And so this cat being dead and alive, when you open the box and observe it, you become in a superposition of thinking the cat is dead and alive.
Right.
And though we call it many worlds interpretation, it's kind of a misnomer. It's just one world, but it's a world that's incredibly complicated that contains many possibilities simultaneously.
Well, I've heard some physicists even explain it as there are multiple universes that are connected. We just don't have access to them directly, or maybe we do. I guess we would, just we're not aware of it. But
under ordinary circumstances, it's very unlikely that you would be able to interact with this rest of the universe. And it's not like, oh, we just need to build a better experiment. It's probably unreachable in that sense. So you can think of the universe as having many, many pieces to it, but some of the pieces are completely disconnected from anything you and I will experience. And most of them, I don't exist and you don't exist.
Right.
Things like that.
Most of them, life doesn't exist. But also, there will be an infinite number of universes where everything's the same. There's every possible variation of the configuration of particles. And even there's even an idea that electrons jump in and out of other universes. They move through other. I know in quantum computing, that's what they're. A lot of experts are saying that the electrons within the qubits are moving in and out of other universes or other dimensions.
Well, it's all a matter of how you describe it. You could, in one sense, say, oh, these other universes are completely disconnected. But people who believe in the many worlds interpretation, like me, would say, no, actually, very often we do have the examples of this. The simplest example of this is the two-slit experiment, which I could have brought a tabletop demo with me, where you put a light through a pair of slits, and you can show evidence that, in fact, each of the photons goes through both slits.
Yeah, and you can see the wave function.
So you can think of it as there's one universe where it goes through one slit, one universe where it goes through the other slit, but they're getting combined in a way that's only possible if those two universes interact, or the technical term is interfere with each other. And so many worlds people like me would say that's decisive evidence that many worlds is correct.
Yeah, and also there's the many worlds theory argument with measurement is that if you measure the position of the electron or the spin of the electron, and you predict it as it'll be up, and it's not, or it's not there, then it is there. It's just not there in this universe.
Well, whenever I measure it, let's say I have an electron that's in a superposition. That means a combination of both up and down, which is certainly possible, and we see strong evidence for that. That when I perform that measurement, what happens is I get in a superposition as well.
Right.
So what happens is there's sort of two pieces to the universe, and one of which the electron is spin up, and I know that, and the other one is where the electron is spin down, and I know that it's spin down, and both of them exist. Both of them are equally valid.
Right.
And were I to make some important choice based on this this spin of the electron, it would then affect the rest of my life, and the rest of my life would be affected by this apparently quantum random thing, and both universes exist. I do remember reading a short comment by someone who was dating a particle physicist, and his girlfriend, apparently, whenever there was a significant event at the particle collider, she would call and say, "Sorry, I got to cancel our date tonight." And his thought was, quantum mechanics is affecting my life in a rather significant way, because it
funny.
determines whether I get to go out on a date tonight or
Right.
not.
Yeah.
So,
Interesting.
you know, and if you think about it, you probably come across butterfly effect or things like this. Small things probably in the end do have large influences.
Sure. Yeah.
Butterfly effect usually refers to the idea that the weather is chaotic. And so the flap of a butterfly wing today can determine whether there is or isn't a hurricane a week from now. And so almost certainly quantum effects ultimately affect large scale life in a
Well, everything's
complicated
quantum.
way that's
Yeah.
hard to predict.
Yeah.
I'm some combination of genes because a particular sperm combined with a particular egg in my parents, and I was born, and that's a very small thing, but it affects whether I exist or not.
Right. I have this intuition, and I had this intuition before, just based on reading lots of different theories of particle physics, and then when this Nobel Prize came out, or this study came out last year, it seems like it's very possible that all of reality is just information. That information theory could be the base of reality instead of quantum physics, and maybe that's why there isn't a theory of everything, because maybe everything follows some underlying rule that's based on information theory.
Well, the assumption of most physicists is that there is some sort of mathematical theory that describes everything, which we
Right.
do not possess at the moment.
Right.
Or even if we do, we don't understand it. We do have this candidate theory called string theory. I'm not an advocate for string theory, which the claim is it could be a theory of everything. I don't know enough about information theory to say how logical your speculation is.
Yeah.
It may not be some sort of simple mathematics. Maybe it's information theory. I don't know enough about information theory. The universe is incredibly complex, so you need a lot of information to describe it, which perhaps information theory can handle
Right.
such a complex description. I can't say anything negative or positive about that speculation.
Sure.
Nothing wrong with it.
I think the implications of it are pretty interesting. Like if it is just information, if it's a singularity of information, then I think our concept of time and space could completely change. Because then the ability to maybe travel through space or through distances could be completely different for us in the future, maybe completely counterintuitive. Maybe the far end of the universe isn't, billions of light years away. Maybe it's there's a different way to get there. They just created a wormhole in a quantum computer this year.
Well, I believe I can't remember what they did with it. It's quantum computers can do some remarkable things.
Yeah.
It's not creating a physical wormhole that allows people to transport from one place to another. It's probably a situation of transferring a small amount of information from one place to another.
But it was a physical wormhole, though. So
a physical
in that.
wormhole would require the distortion of space and time, which I'm sure they didn't do, because if they did, that would be scary because it might destroy the Earth, and it takes a lot of mass to do that.
Yeah,
But
you'll have to read it. It was I can't remember exactly how they described it, but it was an actual wormhole. But yeah, it could have been. I mean, it was very tiny, but obviously it was.
right. So what we do know is whatever the underlying theory is, it must somehow conform to the macroscopic world we have. So
Right.
in everyday life, things seem certain, for example, and when you take quantum mechanics, one of the things you have to explain is, why do things seem so definite in the universe around us? And also in the universe around us, we seem to only be able to influence things nearby. If you have an underlying theory, I mean, we can always say, well, who knows, maybe Star Trek will become true. Maybe we'll find a way to travel faster than light, but it doesn't look very probable. Furthermore, if you had something that allows you to travel faster than light, you could also probably travel backwards in time, which creates confusing paradoxes.
Right.
But indeed, some of the ideas you're saying, like space and time, may well be emergent properties. They are not fundamental properties, though our current theories are sort of built on a space-time structure. Space-time manifold is the right term. In general relativity, that doesn't mean that's the ultimate theory. There
Right.
may be some underlying theory, and maybe there's some way of cheating this light speed limitation.
Have you ever read any of Dr. Donald Hoffman's work?
I have not.
He's a really interesting scientist, but his team is they've been working on thinking of reality as more of as just information, and thinking of what we are or maybe the best way to describe it is, as the information becomes more complex, that maybe where consciousness arises, and then we're these conscious agents within the information, and everything we experience is just our interface with the other information. So it's more like an illusion that time and space is a physical thing, but it's really just our interpretation of the information.
Well, for example, time is something where, if you look at sort of quantum cosmology, which is sort of this slightly dubious, let's try to figure out how quantum mechanics would work to describe the entire universe. Time is typically not built into it inherently. What becomes more relevant is things like relative time. How does this time, you can say this event came before that, but neither of them occurred at a specific time. You
Right.
can only talk about which one came first.
It could be that everything's happening simultaneously, correct?
Yeah. So in such pictures, time kind of doesn't exist. And nonetheless, you can ultimately get out of it a way of describing things that makes it look like time does exist. So yeah, I mean, I think ideas like this are probably correct. In terms of consciousness, it's, that's almost an area for psychology. A great many of the things that we think, consciousness is, psychologists have proven it's not.
Right.
So we often think of it as, well, it's our will making choices and so on. And in surprisingly large number of circumstances, they can say, well, you have a lot of influences on that you aren't aware of why they're there. We like to think of, well, people are good or bad. It's sort of an inherent property of people, but they've done experiments where they discover that people who walked past a Cinnabon are more likely to do an altruistic means than people that came the other direction that didn't go by the Cinnabon. And you're like, well, you'd kind of think good people do it and bad people don't.
Yeah.
But something as ephemeral as that can change your personality. So we don't know what consciousness is. We just know a lot of things it isn't.
Yeah, and I think also on that idea, I think the idea that we're separate, and that that we're separate from the rest of the system or the universe is sort of a flaw in our thinking. I think that it's all one thing, and it's all connected, and it's all influencing each other itself. Everything affects everything else, and so you can't help but be a product of your environment, or of biological processes, or
Well, I think, this sort of gets back to many worlds interpretation. Almost all physicists would agree that quantum mechanics works pretty well on a microscopic level of explaining how things work. And then you have this problem that when you perform measurement, it seems to break the usual rules of quantum mechanics. And that's because I think people want to say, well, I'm not in superpositions. I'm not in this complex thing. I'm just observing this complex thing.
but you have to be.
But when I interact with it, I become part of it. As soon as I become part of it, if you just followed the laws of Schrödinger's equation, you too will become this superposition of
But that
things.
should be with everything we experience, because we're constantly or observing.
Yes.
I mean, I'm observing you right now, so something is happening on that level. We just don't understand.
So there's no question that there are photons reflecting off me, entering your eye, and then getting processed in some complicated way by your brain.
Right.
And we don't know which random things are influencing me to say one thing and ultimately influencing you. But
Right.
yes, the universe is a connected whole in quantum mechanics. I don't know how that changes things. I mean,
It doesn't make it. Yeah.
I've heard people say, oh, well, that means we should all love one another. And I said, well, I've known for a long time that people and animals have a common ancestry. Maybe that means we shouldn't eat animals. I'm not going to argue that, but
Or maybe
my
that just means
point
we're
is-
eating ourselves.
Sorry?
I think it almost means we're just eating ourselves.
Yeah. But I mean, the truth is I'm also related to plants, and I've decided
We eat those
not
too.
to give up on that.
Yeah.
So
Right. It's almost like one, so let's jump into the physical reality real fast. So it seems like planets are almost like seeds. So when a star explodes and all these heavy materials are created and they eventually become planets and new solar systems. It seems like you can almost think of a planet as, we don't know this yet, but I think we'll probably discover this maybe in the not too distant future. But it seems like planets are almost like seeds, and if they're in the right circumstance, or if they're in the right, if the environmental factors are right, then these seeds start to grow, and then you see it allows complexity to emerge, and eventually it becomes life, and then it becomes maybe consciousness. Well, for sure here there's levels of consciousness, and then and I don't even know. Maybe that's what technology is. Maybe technology is just part of that evolution of complexity, and maybe technology is whatever we are becoming something that doesn't have to eat itself. Yeah.
Well, I don't know. And you make it sound almost like there's a plan, and I don't want to speculate.
I don't know
on
that's
that.
a plan. I think maybe it's more like the game of life, where it's just maybe the nature of the universe is complexity, just becoming more and more complex.
Well, the universe is wonderfully complex, and we don't know why. I mean, you could speculate on a universe so simple that life has no possibility of existing.
Sure.
I don't know whether your listeners knew all the references you were making, but we don't know how often life arises. Right. We have a pretty good idea that life requires at least some pretty complex molecules, which includes carbon typically.
Right. Which is very common, right?
It is. However, when the universe was born, it was very rare, or pretty much non-existent.
Yeah, it takes.
So what happened was there were early stars that made carbon and other elements, and those went on to seed the formation of other stellar systems, including our own, and ours had enough carbon and iron and everything else that allowed humans to be formed. There's something like 30 critical elements for human life.
I think we don't appreciate what we are. We used to be in the core of a star.
Yeah.
And that's really amazing.
Not the hydrogen in your body necessarily, but
Sure.
which is in the water, but all the carbon, oxygen, nitrogen, and all the other elements. Really, in the Big Bang, before there were any stars, all you really had was hydrogen and helium.
Right.
Helium doesn't play a role in life, to my knowledge. Hydrogen is critical for life, but the rest of the elements in your body all came from stars, or as Carl Sagan likes to say, we are star stuff.
Yeah.
Is there a sort of a naturalness that things become more complex and lead to ultimately to technology? I don't know. We don't know how common intelligent life is. We know that it's kind of rare, but it's a big universe out there.
Robin Hanson has some interesting theories about that.
Yeah, well, of course, the big puzzle with that is that if it's common, how come the aliens didn't show up? And,
well, the universe is so vast too, and they may.
It could be that there's a lot of explanations for this. It could be that the universe is so big that even with arbitrary technology, it's too hard to travel between stars. It could be that some races have arisen and just said, well, we don't want to go mess with what's already there.
Yeah.
It could be rare enough that we're the first in the galaxy and everything else is too far away to reach us.
Yeah, there's trillions of galaxies too, so it wouldn't
there
matter.
are many, right? So you could have life in many galaxies, and maybe we're just so far away because galaxies are incredibly far away. It's very hard to figure out how to get across those vast distances.
Have you read the theory that that it could be that once societies reach a certain level of complexity, they become what we observe as black holes?
I haven't. Black holes do contain a vast amount of information.
We could be in a black hole, right?
Yeah, well, there's sort of this holographic theories, which basically say that you can kind of have a two-dimensional universe that looks like a three-dimensional universe.
Yeah.
That's mostly just idle speculation, but that doesn't mean it's wrong.
Right.
And in a sense, the universe is a little bit like a black hole, but not quite, because it doesn't quite have enough mass to recollapse on itself. So, but I don't know. You can say things like that, and then you don't know. I don't know what to make.
What are your thoughts on the new observations from the
James Webb
telescopes? They found that now they're saying the universe is at least 27 billion years old instead of 13.8.
That number
14.
I haven't heard. So that would be interesting. I haven't heard that.
13. So now they're trying to reconsider the Big Bang. Like maybe it happened way earlier. Maybe it didn't happen. Maybe the universe is just infinite and it's always been.
I think it's fair to say that the vast majority of people who study this have the attitude that the universe is probably pretty close to 13.8 billion years old. That should be said with some caveats.
They just measured galaxies that are 27 billion years old.
Well, galaxies are, one of the complications with this is how do you measure time and distance at these enormous distances?
Sure.
So it is almost impossible to look at a galaxy and figure out how old it is. So I would be very doubtful about anybody that says that.
I'd love to hear your take. These are high level physicists that are discussing this, so I'd love to hear your take on it.
One of the problems, there's something describing the rate of expansion of the universe, which is called Hubble's constant.
Right.
And there's a long history of this, but the current situation is there's a group that says its value is in some units that don't really matter very much, 72, maybe plus or minus 1, and another group that says it's 67, maybe plus or minus 1. And
that's a pretty big difference though, right?
Yes. So
in the cosmic scale,
20 years ago,
massive.
We would have been and were very excited that these numbers were pretty close. But now that they're getting better, the numbers disagree. And until we resolve that, we have to acknowledge the very real possibility that there is a huge flaw in our theories about the age of the universe.
That's interesting.
But we don't know which flaw is right, and people come up with speculations and try to figure it out. But the standard number is 13.8 billion, which has a pretty small uncertainty. And that's going back to an event which we call the Big Bang, but we don't know that the Big Bang is the beginning. There could be stuff even earlier than that.
Yeah. Yeah, that's interesting. Well, I mean, there has to be something likely before
I don't
that.
know. If you
Maybe.
have the physics proof of that, I'd be very interested in seeing
I
it.
don't know if it's possible to find that. Yeah. Is it maybe outside of this?
The best guess would be that, so I would say that we don't know that at all. It's quite likely that 13.8 billion years ago was not just the explosion that spread matter throughout the universe. That's a really bad way of describing it, but also
Right.
the beginning of time itself. So
It's
in
more like
fact,
the
there
expansion.
was no time earlier than that. That would be the
Interesting.
best guess.
Have you heard the idea that it could be that, how is this explained? Almost like rips in space-time, like bubbles at the Planck level. Like if something about if space is heated to a certain temperature, it could break off into another universe.
So there's all kinds of ideas along this line. Sort of one of the things that we have some evidence for, so it may actually be right, is that during the early universe, there was a period of very, very rapid expansion when the universe got bigger and bigger and bigger very quickly. Imagine it doubling, not every million years or every second, but every tiny fraction of a second. I'd have to figure out what the units are.
Right.
So just growing from nothing to huge almost instantly. And then the hardest part of that theory is to try to figure out how do you get out of it. So how do you stop inflating? And one idea that's very seriously considered is that what happens is a tiny patch starts to get out of it. But by the time it succeeds in getting out of it, it becomes a huge patch. In fact, it becomes bigger than the entire visible universe.
It just creates a new universe. Basically.
What's happening is in this vastly expanding early universe, universes pop out, but each of them is only a tiny fraction of the total reality. So in addition to our universe, by our universe, I'm going to mean everything that we can see and probably a lot bigger than that. That's only a tiny fraction of the total. And there's these other universes that pop out at different times. And in fact, the vast majority of it has never popped out. It's just constantly expanding and popping out new universes, even now.
Just turtles all the way down.
Yeah.
Just infinite.
Furthermore, many of these other universes could, in all probability, have apparent laws of physics that are radically different than ours. And so if that's the case, then the situation could be there are many, many universes, and the vast majority of them do not have the conditions favorable for life.
Right.
There's just no life. A lot of them are boring universes, or maybe they're exciting in some weird way, but they don't have any life in them.
There is the idea that we can use those universes for computation, though. That's one of the ideas in quantum computing is that
quantum computing is much more modest. It's based on, that's not intended as an insult. It's using quantum mechanics as we understand it.
Right.
And in quantum mechanics as we understand it, you might think, for example, that a computer, if you want to store a certain amount of information, if you want to put the Bible, I don't know, pick your favorite book.
So large book.
You're going to need, billions of bits of data.
Right.
Right. Billions is probably an exaggeration, but many millions of bits. And in quantum computing, we realize that the amount of information, if you have n qubits, is not n, but 2 raised to the n, which is an enormously larger number. Yes. And basically, you can have all of these things, or a large number of them, all doing work for you simultaneously.
Yeah.
So the classic problem that this is used for, it turns out surprisingly that it's a useful thing to be able to take, let's say, a 100-digit number and try to find the factors of it. That's a very hard problem for computers now, right? If you're the NSA, you might be able to do it. Break the code, read my emails. They're definitely reading my emails. Stuff that you want to keep secret. You can break codes if you could do this, if you could
Yeah, that's the problem
factor 100 digits round numbers. That's really hard with classical computers. And even though I say the NSA can do this, in some cases they probably can't.
Oh yeah, that's true.
But with a quantum computer, in principle,
You could break all the codes.
with let's say 1,000 qubits, you could probably do this.
Yeah, just so the listeners know, with classical computers, you have binary code, zeros
Right.
and ones, and it can only be a 0 or a 1. It can't be both. But in quantum computing, it could be a 0 and a 1 simultaneously and infinitely combinations in between.
Yes, and probably most interestingly, they can all be connected. You can have, if you have 100 bits, if you have 100 bits, you don't just say, well, they could all be ones, they could all be zeros, or they could all be a combination, but you could have an incredibly complicated situation where if this one is 1, that one's 0, or if this one's 0, that one's 1, and they're correlated, and they can both be in a combination of them, and there's many, many different ways to do that combination. And that ultimately leads to the surprising power of quantum computers.
And it's such a fragile system. They have to keep it at negative 560 Fahrenheit, I think.
Well, there's many different prospects for what the right way to make a quantum computer is. Most of them involve cryogenics for the ones that have actually been built.
Yeah.
So yes, they have to be very cold.
It seems like in a few years, we'll have several quantum computers in multiple areas, and we'll probably all have to have we'll pay a monthly fee to access these quantum systems just so we can create passwords and just interact with, because if you don't have access to that, then nothing's secure.
Well, it's difficult to know where this is going to go. Quantum computers, I think part of it is we forget how amazing regular computers are, okay?
Sure. Yeah.
I hate to say this, but I have made mistakes in my life, okay? If you asked me to multiply two 10-digit numbers, I'd probably get it right. If you asked a computer to multiply two 10-digit numbers, it would do it 1 billion times and never make a mistake.
Right.
A lot of this is based on the fact that it is a 0 or a 1. And so basically, because 0 and 1 have a big gap between them, if you put in a number as 0.1, try to put that into a computer, it'll round it down to 0. And
Yeah.
so
There's less room for error.
errors can be gotten rid of.
Hmm.
Quantum computers, at least in principle, never lose information. Because they never lose information, they're incredibly delicate. Now, this is not my area, so I can't tell you too much about them. People are working on every one of these problems for quantum computers, because if they succeed, so the simplest problem on a quantum computer at present, if you say, okay, if I say 1 to you, say 1 to me back. If I say 0, say 0 to me back. You can't have a simpler computer program than that.
Right.
They will typically succeed with a good quantum computer, 99, perhaps even a little higher. Well, that's not very good, right? I mean, I can do better than that.
Right. Yeah.
But we need incredibly reliable systems to make practical quantum computers.
And the error corrections are getting better and better constantly.
Yes, they are getting better than this. And
what's this is going back to the information idea, but what was the discovery that the error correcting code of the universe is identical to the error correcting code for computers?
I'm not familiar with this, but I mean, regular conventional computers have error correction built into them in such a way that they are incredibly robust.
Because the the circuits are so tiny now. They're on such a small scale that they're only a few atoms apart. So now electrons can hop from one atom to the other, and it creates errors.
Well, errors have always been a problem with computers. The original computers, I've heard, this may be an urban legend, were done with switches, physical switches, and occasionally bugs would get caught in them, which is where we get the term bugs in computers.
That's interesting. That makes sense.
Nowadays, that's not the problem, but we still have bugs.
Yeah, if we found a bug in there now, it'd be an issue.
So basically, a lot of this stability, again, this is not my field of expertise, because you can only have 0 and 1. It's a very stable system.
Right.
It's got sort of 2 options, and if you are close, it will correct and go to the correct one, and that's easy to do. And with quantum computers, there are ideas how to make this work.
Yeah.
For this problem of factoring integers, it turns out that it's very, very hard to figure out what 2 numbers multiply to make a huge number. It's very easy for conventional computers to check the answer. So you could have a quantum computer that says, I think this is the answer, and then you can just check it. If it's not, you say, try again. And if it's successful, so in some cases, you can maybe live with a little bit of error.
Right. I wonder if they could use, and this will probably be a thing, but maybe with AI technology, they could use that as part of the error correcting solution.
Yeah, well, we don't really understand how AI works, right?
Right.
I mean, there are people that know a heck of a lot more than I, and I've read
fascinating.
about neural networks, but as
Yeah.
I'm sure you've heard, these outputs from ChatGPT, for example, we can't say why it came out with the answer it did, right? And
what's interesting about it to me is that it's all it's doing is it's predicting the next most likely word to be accurate, and then and it's taking tremendous amounts of data from humanity. So it's
right.
I almost look at it as like a it's almost like an expression of the collective consciousness that it's tapping into, and it's almost like we're asking ourselves simultaneously questions, and then it's just giving us the most accurate response based on what we would respond based on the information that we know.
Yeah,
and that's
well,
probably what we do, right?
It could be. The problem is that it makes mistakes, and we can't really trace those
The
mistakes.
hallucinations, yeah.
Maybe it's because hallucinations is the term they use. Again, not my
But
field.
could those just be ideas?
I mean, it could be just something that, but I find that a little hard to believe, because they have questions like, and I'm making the number up, they'll ask the computer, is 11,347 a prime number? And ChatGPT says no. Well, the answer is yes. But
Right.
was there some person out there that asked this question and answered it incorrectly, and it's just...
Well, what's also weird is if it does that, you can say, "Are you sure that's correct?" And it'll say, "Oh, I'm sorry, that's not correct." And then
Well, I haven't followed all of this, but
it's
you can
fascinating.
get some rather bizarre conversations from what I've seen of ChatGPT, just looking as an outsider. I've never tried it myself.
Oh, I've used it quite a bit. It's interesting.
Okay.
And I use Google's Bard a lot because I like the Bard isn't as it's not as good of an AI model as GPT, but it seems more intuitive, and it's also it feels more like you're talking to a human than ChatGPT or GPT-4.
Maybe, I mean, as a professor, it doesn't affect me too much, but I have in the past had classes where I've taught where I've said, okay, as your final project, you can write a term paper on Jupiter's moon Io. Well, with ChatGPT, you can do that in less than a minute.
Yeah.
And I'm going to have a hard time reading it and telling that you didn't cheat.
I think I've thought a lot about this, especially from a business perspective, because it's the most disruptive technology that we've ever seen. And then, but I feel like the way to approach this technology is to just approach it as an extension, because it's moving so rapidly. And I follow a lot of the top experts in the field, and because to me, I feel like it's going to be it's going to be the technology that affects my life more than any other technology.
I assume you read the story about the lawyer who relied on ChatGPT for a brief that he gave to the judge.
Right. Yeah. Bad idea. But it's also a thing where I would say within most top experts in the field are saying that within 2 years, if you're a lawyer and you don't use AI, then you're behind, or any business, and it has the ability to replace any job that is currently in front of a computer. But I don't think it has to. I think, like with programmers are now technically obsolete because these AI models can do any type of programming. They do it better than humans. They do the most complex programming. They write the code better than people can. And
Maybe true, but I have my doubts about that. I do have one daughter who's a computer programmer, and she says they're not really there yet, but
well, I think
I could be wrong.
I think what the I think what they'll I think this what I hope happens is that instead of laying off a bunch of programmers, they actually just allow the programmers to use the AI to make them more efficient. And then suddenly, well, I know a lot of the big AI companies are already doing this, and a few months ago, their programmers were already 20 times more efficient. So,
Well, I can believe that this will be a very important tool. And I do agree that this is going to cause vast changes in the near future.
yeah.
I'm not sure what this has to do with quantum mechanics, but I'll talk about it anyway. Yes, I think it's going to cause big changes. For me personally, I have the advantage that I am close enough to retirement
Right.
that they're
It's
going
not
to
really
have
your
a
problem.
hard time firing me.
Yeah.
After which I don't have to worry about whether I get paid for what I do anymore.
Well, we live in a human world, so I think it's important to have humans in these positions. I think the advantage is, I think technologies like this. I mean, there's also the fear that people who like power could use it against us, but hopefully, technology is typically decentralizing. You've seen it in like the entertainment industry, especially in music. You know, now you have, instead of having just a few gatekeepers and just a few huge bands that everybody knows about, there's really, you can see the zeitgeist is going away, and now you have millions of brilliant artists that are able to produce their own music or art, and they have their own little followers. And you and I could be listening to multiple bands that don't even have crossover. Like, we have no idea or awareness of the bands that I have no idea what you're listening to. You have no idea what I'm listening to, but millions of people are listening to each one of these bands. And so there's, maybe they won't reach that superstardom, but they'll have a successful career and they can produce art, the art they want to produce, and do it successfully. And I think with this AI technology, most of the leading experts in AI, like Dr. Alan Thompson,
Mhm.
he used to be, he was the chairman of the chairman of gifted families in Mensa or something like this. And then,
Okay.
but he's been working in the AI field for a long time, for many years, and he's one of the most respected experts in AI. And he thinks that we're 2 years from AGI, and he also
What do you
believes
mean
that
by AGI?
artificial general intelligence, where
Okay.
the AI can do everything mentally and physically that humans can do, and he believes that we're not far from a world where we all have our own personal AI assistant that's really more like an AI coach, like a life coach that can instruct. Because there's a big
I
problem.
assume you've seen the movie Her.
I haven't seen it. I need to watch. I'm going to
You
watch it.
need to see that.
Yeah, I know it's I can't believe I haven't watched it, but he believes that we'll have our own personal AI life coach, and so currently there's an issue in society. If you're not a good problem solver, you're going to have a difficult life, and that's a large percentage of society. So there's still a big issue with poverty, and which is a shame that we're as advanced as we are, and we still have such a big issue with poverty. But
Well,
these
unfortunately, some of these advances tend to work that way because it becomes very easy if you're incredibly creative to get super rich. But if you aren't incredibly creative, it's hard to find a job for you.
But as technology advances, it seems to make things more accessible. And I mean, think of this studio, for example. This studio would have cost tens of millions of dollars just 20
You
years
don't
ago.
want to give your secrets away. You want to pretend you spent that on it. You
I-
invested 20 million here.
I think every actor, artist should build a studio,
Mhm.
because I think that's the future. I think that you need to. It's like the SAG. We just talked about the SAG strike. I'm a SAG actor,
Mhm.
and I feel like the SAG strike is really more of the union trying to remain relevant, because this decentralizing technology is coming, and it may make them irrelevant, because
I don't know. It may make actors irrelevant. Why pay an actor a
Well, that's
ton of money when
the-
you can create an AI generated
certainly a business
actor
would do
that
that.
does the same thing?
I agree. Yeah, because corporations, there's a flaw in I think corporate regulation on that high scale. Because a large corporation, the corporation's goal is to make profit, and the corporation's CEO's primary goal is to make that company. Their loyalty is to the shareholders, not to the customers or anyone else. It's
the employees
or the employees, is to make as much money as possible in whatever legal measure. So that's where we get into that paradox of corporate corruption and political corruption and stuff like that. But I think as an actor, as an artist, I can take a screenplay that I've written. In 2 or 3 years, I'll be able to take one of my screenplays that I've written. I'll be able to take my persona, or what's the word? Well, I'll be able to create an avatar of myself, but my likeness. I'll be able to take my likeness and put myself into my own screenplay that I've written, and create. I use other actors that I know and take their likeness and put them in the film, and we could all collectively produce this film very quickly, and it would be higher than a Hollywood level film. And we just did it ourselves. We don't need the studio to do it. We don't need the union to help us do it. We just do it and then put it out there, and people appreciate it.
You may be right, but the studios may be able to do it better than you. They may just say, hey, we need another blockbuster. Press the blockbuster button.
Well, 20 years ago, you'd have to have a big studio to build this studio. But now I don't need the big studio. I can just do it myself.
Right.
And I think that's, it's like your phone. If you go back to the 80s or 90s, I mean, how many millions of dollars of technology is in this? That's now just, they want to give these things away just so you'll use them. So I think with AI, it's kind of the same thing.
We had I think it was the head of IBM as our commencement speaker. This was several years ago, and he said your car has more computing power than Apollo did.
Right.
And
then you had Xerox back in the day who said that computers were dumb and we're not going to invest money in those. And
yeah, well, there's a lot of examples of people who made stupid decisions along these lines.
It's that linear
I think it was
thinking.
Bill Gates that said 64K ought to be enough memory for anybody.
That's funny. Wow. I remember my first computer had had a 2 gig hard drive, and it was enormous. It was like, wow, 2 gigs.
I might be a year or two older than you.
Yeah, it's like, yeah.
Yes, my first programming was on the Commodore 64, and they were bragging it had 64K.
Yeah. Well, at the time, that was state of the art. That was.
Yeah. Well, for a personal computer, that was state of the art. Of course, there were big computers that had a lot more.
Sure. Yeah.
And nowadays, the big computers from them are tiny compared to our small computers now.
Right.
And
yeah.
Tiny, not physically. Tiny in terms of memory or whatever.
We're not far from having laptops that have the same computing power as the brain.
Yeah, the brain is connected in ways that we don't understand.
Quantum Yeah. And there's also
to
some
me,
quantum
it's weird
processes
that
happening
something
there.
like ChatGPT can simulate a human. In many ways.
Well, maybe consciousness is more based on complexity and horsepower than the number of neurons. Maybe the reason we have so many neurons is because we're operating on such a low voltage.
Well, we connect our neurons are connected to many other neurons, whereas in most computers, each of the gates is connected to only a few other gates.
Right. Yeah.
So that is one difference. But I don't know. Nobody knows if that's the inherent difference that's kept humans still superior to computers in certain circumstances. Obviously, if I want to multiply a pair of 100-digit numbers, I'm not going to even try to compete with a computer.
Right.
But in terms of us having a conversation, I can beat out any ordinary computer. But it's getting a little scary. It's getting so that I'm not sure how long that's going to be true. As you said, could be 2 years.
Well, I know Dr. Thompson he puts out these reports. They're like progress reports on testing. And currently these AI models are out testing humans on everything. The highest, it scored 100% on the psychology exam, so, which means that it's so powerful in that area we can't even test it because it's beyond us.
Right.
And it just outscored humans in empathy. I think it was, I want to say it was maybe Google Palm's medical AI. It outscored doctors in empathy, which is amazing. A computer outscored humans on empathy.
Well,
How do you measure that?
yeah,
There's a little
measurements
subjective,
are,
but-
of course, in fairness, the measurements are always a little ambiguous.
right. Yeah.
But yeah, it's hard to find objective tests that people are still a lot better at.
Yeah.
Though in terms of navigating the everyday world, I do much better than a computer, but I don't know how long that's going to be true.
Yeah, because there's several companies working on humanoid robots and other types of robotic systems that use these AI models. And now the AI models are becoming familiar with the physical reality, and their rate of growth in AI it was 12x 6 months ago.
Hmm.
So it could be 24x now. It's so rapid. It's neck breaking.
And with the, since I assume you follow business and how these things relate to that, it's hard to see what's going to happen to a lot of jobs. We don't, for the most part, have self-driving taxis, but we know they're around the corner. And
Well, they're here now. I think they're
they
bringing 2 to
exist.
Greensboro.
Do they?
I think
Okay.
2 are coming to Greensboro this year.
Right. It's sort of at the experimental level, but that's going to change.
Yeah, but
And
in
then
San
what happens
Francisco-
to everybody that does it?
Right.
And what happens to, you can say, well, they can write screenplays and then produce them. And I'm like, that's actually kind of hard. Most people can't do that.
Right. But
and-
if you have a super genius life coach that is an expert in everything, it could teach you.
Yeah, it might be able to teach you, but it might
Or whatever
teach-
you're interested in, That's
it's never going to teach me to be a better taxi driver than that regular taxi driver. Yes, maybe it can teach me to be a screenwriter, but will I be a good enough screenwriter that I can make a living off of it?
well, you won't be a taxi driver for sure. I think.
Yeah, I've decided not to be a taxi driver anyway.
that's,
Fortunately,
Same,
as a
yeah.
physicist, I'm safe a little bit longer
Yeah,
because for whatever reason, my students do like my teaching, and that's got to keep me, paid for the next few years.
Right.
At
Well,
which
you know what?
point-
Maybe you get paid. Maybe you just use your likeness and create an avatar of yourself that can go and teach people forever.
and thereby unemploying all the future physicists that want jobs like mine.
Well, the good thing about education in the future, I believe, with this technology is I think if you're in class, which you probably won't be in a physical space, you'll probably be just wearing your headset or glasses or whatever, but you'll all be in the same space, the same digital space together. And then you could still be there as a professor. But it likely won't be you. It'll be maybe your avatar, some digital version of you, some AI version of you. And as you're teaching the class, or maybe you have a student that has a question, well, you're also able to answer that student's question while...
My avatar can. I can't.
Right. Yes. And then...
I've tried that. Students will sometimes, I've taught classes on Zoom, and students will sometimes try to put questions in. And it's actually probably generally better to not answer, to answer the questions in public, because if one student has the question, everybody probably has the question.
Sure. Yeah.
So,
I think education is going to be really interesting in a few years.
I think a lot of things are going to change. I don't know how big it is, and one thing I'm quite certain of is that the people in Washington who can't pass a budget are not ready to handle this.
Well, I think that my hope is that these systems will fix them, fix that problem, because their interests are not aligned with ours, certainly. And I think when we're so connected, and also we're not only we're so connected, but we also have a super genius with us at all times, it's going to be really hard to trick us unless they control the super genius,
You can say that, and, you can look at when the internet came out and it was like, well, this is going to be great because everybody's going to have access to good information. So all of a sudden, everybody will be much more educated. But it's going just as much the other way, where vast numbers of people are being fed misinformation all the time.
Well, I feel like we're just in a transitionary period, and I think we're also seeing where these large corporate media companies, they're not real news organizations. They're corporations. They're entertainment corporations, and they have They have certain alliances with with other investors or with advertisers and stuff like that. So they're going to be biased towards what makes them money. Whereas you have independent journalists that are reputable journalists that are professionals that are doing what they do because they believe in journalism and not money.
Yes, and you have
And
people that are paid to be misinformation agents who are
sure,
working
you have
against
both.
them.
But I think we're not far from a world where we have an AI assistant that can help us sift through this stuff instantaneously.
Let's hope so.
And a lot of these things are subjective too. So it may be where you ask your AI, like, is this true or not? And it says, well, if you feel this way about this thing, then this is the truth. If you feel this way about this thing, this is the truth. And these are the two positions or multiple positions on this topic. And if people align on these different issues together, then this is where these issues could potentially lead.
Yes.
And
but
so,
I mean, I would like to get to a point where you say to your AI, did the moon landing happen? And it says yes.
yes.
It doesn't say, well, there's these people that believe it did and these
Right.
people that say it didn't. I want it to give me the correct answer.
Right. Well, that's not a subjective thing, though.
That's true, but
yeah.
I can assure you there are lots of people that believe it never happened.
Sure. And then I guess there was some footage and stuff that was maybe they shouldn't have put out, that was maybe created just to promote because it was sort of a there was sort of a Cold War type battle too with technology, and maybe we didn't have the technology to record the event as much as we would like to, like on the scale we would like to. So maybe they created some things that to sensationalize it even more instead of just being factual. Because certainly there was a lot of propaganda was easier when there were 4 or 5 networks that controlled all of the content. And so.
Well, there's certainly propaganda that was happening back then, principally about things like Vietnam War and stuff like that.
Yes, exactly. Yeah.
Obviously, there was
or like Kennedy,
there was information that was being hidden from the public at the time, but in this case, the new technology, television in particular, was such that it was much harder to hide things because
today it's very
people
hard.
Saw it on TV.
But it's also
today we have a different problem that people can create fake videos.
Yes, and there's so much information. It's overwhelming.
Yes,
that's why no one's interested in things anymore, because there's it's information overload.
And AI will allow us in principle to sift fact from fiction, but you have to know it's also going to be used by bad actors.
Oh yeah,
to try to muddy the waters even more. It's already being used that
sure.
way.
Yeah, or even manipulate our lives or control us.
Yes.
Yeah, but hopefully, there's people like Ahmad Mustak who owns he owns one of the large AI companies, and all of their stuff is open source. And he believes, and most experts believe, that if it's open source, diversity is always better. The more diversity you have, the faster the technology moves, and also the more decentralizing it becomes, the more democratized it becomes. And so I'm hopeful that those technologies will rise to the top, and those will be the ones that we access and we all use mutually.
We'll see. I hope that your optimistic view is correct.
Me too.
bear a mixed view where I see the benefits, but I also see the risks.
Yeah, I'm cautiously optimistic.
And on the purely negative side, I shouldn't say purely negative, on primarily negative side, it's going to be disruptive. Everybody, I think you would agree with that.
Yeah, it's going to be
whether we can adapt to that disruption fast enough is hard to tell.
Yeah, the transition is going to be rough, I think, and we'll start seeing it probably at the end of next year, like really heavily. But
hard to tell whether it's already happening. I mean, there are jobs that are becoming obsolete, but this has always been true.
Always.
There's always been changes in technology that have made jobs obsolete.
I'm just hoping that this technology, if it takes your job away, it'll help you replace it with something better. That's the hope,
I mean, we have a lot of people that mine coal, and it's pretty clear that
It's not good for you.
whether or not it's bad for you and is bad for the environment and it's bad economically. It's getting to the point where it's not even if these other factors weren't there, coal is dying anyway.
Yeah.
And what do you do with a coal miner? And,
Well, he could learn to code now. He doesn't have to.
Allegedly.
You just have an AI agent that can just work for you. Technically you could have all of your AI agents could just pick up work for you. They could go out and find work and do things for you to create income. So maybe that's something that happens.
Yep. I don't know how
So
the
many
economy
possibilities.
works like that. If I own 10 AIs, do I get to make 10 times as much as you?
Right.
And then it turns into sort of an investment economy where whoever has money can make more money.
Yeah. Or money just doesn't mean anything anymore. They could reach that level too.
Yeah, that's hard to imagine because there are things that are limited in amount and some of us want them. I don't particularly want a yacht, but if you want a yacht, not everybody can have a
Sure.
yacht. So
I think it depends on how well we learn to harness energy. I think we're out of time. I know you need to.
yeah, I do
Good.
have something I have to get to, much more mundane than most of these discussions, but
Well, Dr. Carlson, it's been a real pleasure.
it's been nice talking to you.
Love to have you back in the future too, and maybe continue the conversation.
Thank you.
Yeah, my pleasure.
Next time I come, though, can you arrange for some better weather on the way here?
I'll do my best.
Thank you.
Oh,
Thanks
yeah.
for having me.
Yeah, my pleasure. Well, hope you guys enjoyed the episode. If you did, be sure to like and subscribe. We'll see you next week. Bye, guys.